Fine. So what is Docker? What is Docker? What are the importance of Docker? Right. So what are the advantages of Docker? So in real-time projects, why we are using Docker containers? Let's try to understand. Okay. What is Docker? Basically, what is Docker? Docker is a container tool. It is a container tool. Docker is a container tool. Yeah. So what is container? What is container? Container is a lightweight, standalone executable program. So container is a lightweight standalone executable program, or else container is a just like box. In general, what is container? In general, what is container? In general, what is container? Anyone? Just like storage box, right? Yeah, it is like a box. It is like a box. We can move anywhere. We can use anywhere, right? So this containers we can move anywhere. We can use anywhere. Yeah. So far what we did, we created a server. We created a server. On top of that, we installed all the packages, right? Like for example, we created a server. On top of that, we deploy all the applications like Git, Jenkins, right? Maven, Ansible, like that. So yeah, from now onwards, what we will do, we can install configure on containers. We can install configure on containers. Okay. Yeah. So containers are advanced to virtual servers. Containers are advanced to virtual servers. Okay. Fine. Yeah. For example, if you want to deploy, if you want to deploy operating system on your server, we required one we required one ISO ISO image, right? So to deploy operating system, install OS, install OS, we required ISO image. What is ISO image, anyone? What is ISO image? It is a full-blown operating system. So in this, we get all the features like plugins, patches, graphics, updates, paintbrush, media player, right? So normally when we deploy operating system in our laptop, we get all the features, right? Yeah, this OS image size would be 6 GB to 18 GB. This image size would be 6 GB to 18 GB for operating system. 6 GB. Why I'm saying 6 GB to 18 GB? Like different flavors we have. Windows, Linux, different flavors, right? So for example, RHCL will take 7.5 GB, right? And Ubuntu it takes 6 GB, and also Amazon Linux it takes 6 GB. So if you take Windows versions, latest versions, those take 18 GB, 17 GB, like that. Okay. Yeah. So it would be 6 GB to 18 GB. Yeah. This is a full blowing operating system, right? So in server, when we deploy operating system, it is a full blowing operating system. It takes 6 GB to 18 GB. And also when we restart server, it takes minimum 4 to 8 minutes. 4 to 8 minutes. So server, we are talking about server, right? It can be any server, virtual server or a physical server. Okay, virtual or physical. Fine. it takes 8 to 4 to 8 minutes when we restart the server. So why it will take 4 to 8 minutes here? Because server having all the processings and applications, backend applications, and memory check, everything, right? So one by one all these services will be restart and server will be restarted. So within 4 to 8 minutes, 4 to 8 minutes. Okay. So if you restart laptop or desktop, it takes 30 seconds something, right? Normally. But server side, so because server is having high computing power, right? So in server, we deploy different applications, operating environment. So multiple disks will be there, multiple RAM models will be there, multiple processors will be there. That is why it takes 4 to 8 minutes to restart the server. And also here, deployment time and downtime is high. Deployment time and downtime is high, right? So when you deploy any packages on yeah, server side, okay, it takes some time. So when you down the server, what is downtime, anyone? Downtime, what is downtime? It's a maintenance time, right? So when we perform any activity, make sure the server should be restarted. The server should be, yeah, stop and start cloud if the cloud server is cloud server. Okay. So when we start the server or when we restart the server, the changes will be reflected, right? Yeah. So it takes 4 to 8 minutes, and also deployment time downtime is higher in server side. Okay. Yeah, these are all the things available. And also moreover license cost is high. So operating system license, application license, right? So all these licensings are very costlier here. Okay. Yeah, these are all the things available in server side. So when we talk about container, okay. So here install OS, we required Docker image, right? So this image size would be 200 MB only. When we use Docker, when we deploy operating environment on container, so the image size would be 200 MB only, right? So yeah, with all applications, all configurations, maximum it takes 650 MB only, right? Maximum 650 MB or 700 MB or 800 MB. It is in MBs only, right? Not even 1 GB, right? Yeah. So here 6 GB to 18 GB. Here 200 MB, 200 MB to 650 MB, right? Yeah. So when we restart container, it takes 30 seconds only, not 30, 15 seconds only. When we restart container, it takes 15 seconds only. So even though, yeah, the user who is working on the container, who is developing the applications on the container, so he doesn't understand if the container is restarted or not. So containers are very faster, very advanced one, right? And also deployment time and downtime is very less. So when you want to deploy any applications, right, you can deploy very faster, you can deploy quickly. So when you down your container, when you restart your container, it takes 15 seconds, right? Yeah. So when you want to have any maintenance activity, right? So you can down, you can up immediately. These are the advantages of containers. Okay. So that is why most of the project teams they are using Docker containers. Currently, most of the project teams they are using Docker containers. Okay. Yeah. Next one, important one. Yeah. So application high level architecture. Okay. So Docker application high level. Yeah. Normally we can any application. Okay. Not Docker. For example, any project team, if they want to develop any application, if they want to perform any application development, or if they want to deploy an application, right? So they required three components, important components. They required three important components, right? So what are those? What are those? Three important components required. Every project team they required three important components. What are those? Right? Yeah. So first one is front end. Second one is back end. Third one is database. So any application, not only Flipkart, not only Amazon shopping site, right? So any application required three major components, right? Which are like front end, back end, and database. Front end, back end, and database. So front end, what is front end? Anyone? What is front end? Anyone? Front end is a front end UI, right? It is a UI, front end UI, right? Yeah. So normally front end UI. So any user when they want to check the application, for example, if you want to book any product in online shopping, what we will do? We can access the website. We can check the products in front end, right? So normally front end, it is a UI development. UI development. So to develop this UI, the project team use HTML. Normally, when if you want to develop any developer, if they want to develop any front end UI, they use the HTML, CSS, right? JavaScript, etc. These are the major tools to perform the yeah, to perform the front end UI, to develop the front end UI. These are the major tools they use. Okay, yeah. And also, what is backend? Anyone? What is backend? Anyone? So backend is nothing but so API development will be happened. So backend is nothing but API development. Okay. So backend API development, application program interface development. So normally, for example, if you go to the Flipkart website, so this is UI, front end UI. So backend, so here we have so many products are there, right? So when you click on this, these are all microservices. We can say these are all microservices, right? These are all microservices. For example, if you click on any product, so these are all microservices we can say. So backend team, what they will do, they modify the code here. For example, these are the offers, only five left, bank offer, lowest price in the year, right? So like that, they are showing something here, right? Yeah. So who will modify this? Who will modify this pricing, offers, right? So out of stock, sometimes out of stock they show. Sometimes what they will do, they modify the product. They change the picture here. They change the image, right? So we'll modify this backend application team, right? So backend application team they modify the products here. Okay. Yeah. So when they modify the product in backend, so when they submit to the server, so this pricing will be reflected. Okay. So backend API development will be happened here. Okay. So for backend development, so normally they use the tools like for backend development. Yeah. So major tools here, Java Spring, and Ruby, Python, etc. These are the major tools they are using to develop the backend development, right? So database, next one is database, right? So why we require database in application? So why we require database in application, right? So for example, in the Flipkart, when I want to create my profile, when I want to create my profile, so where the profile will be created? When I click on profile, when I update the profile, when I modify the profile, when I add the profile, so where the profile will be saved? In the local database only, Flipkart local database only. And also, so whenever we click on any product, what will happen? That will that will redirect to vendor side. So Flipkart is a mediator, right? Product vendor is different. When I click on this product, it will redirect to the Flipkart. We redirect to the vendor side, right? Yeah. So it will, yeah, will get the information from vendor side. So some of the products will be saved in the Flipkart website only, Flipkart local database only. So because that is why, so when we book any mobiles or any other products, they deliver within the same day. Within the same day, they deliver, right? How they can deliver? Because they stored in the local database. They stored in the local warehouse in the same city. That is why they deliver within 4 hours, within 5 hours, right? Sometimes we get the product, right? Yeah. So when we talk about database here, so major databases here, Oracle database they use. Oracle database, MySQL, Cassandra, DocumentDB, etc. So these are all the major databases we are using, right? Yeah. So any product, so these major three components required here. So any product, so when they want to save any products or any customer, they want to store their profiles, right? So we required database. Database is must. Without database, application will not run. Okay. And next one, for example, if you want to run any application, if you want to run any application, so all these services should be run. So for example, if I want to run my Windows, if I want to run my Windows, yeah, if I want to run my Windows, these are all Windows services should be run. If any one service is down, Windows will not run properly. If I want to run my Windows, it starts with Win. All the services should run properly. Otherwise, Windows will not run, right? So if you want to run Jenkins, all the services should run properly. Otherwise, Jenkins will not run, right? Why we are talking about this? So we have application style. We have application style. So we are talking about application style. In application style, we have two types of applications are there. First one is tightly coupled. Second one is loosely coupled. What is tightly coupled? What is loosely coupled? So these are very important. Okay. In Docker, so tight, not in Docker, any application. So tightly coupled, loosely coupled. What is tightly coupled? So here, for example, so we are using in Flipkart, we are using these are all microservices we are talking about, right? These are all microservices, right? So in tightly couple, if any one component is down, one service is down, application will not run properly, right? So all individual server components are tightly coupled. All tightly coupled. So in case if one component is down, one of the component is fail. If one component is fail, yeah, entire application will be down. So one component is fail, entire application will be down. So which is nothing but tightly coupled, right? So loosely coupled, in loosely coupled, yeah, all the components will run individual. all the components will run individual, right? So in, yeah, if one component is failed, application will not be down, right? So yeah, why we are talking about this? Because our Docker is implemented in loosely coupled. Second one, right? So yeah, whatever applications we are deploying on the Docker containers, right? So those applications will run without any issues. In case one component is down, nothing will be happen, right? So all the components will run individual. One component is down, one component is fail, application will not be down anywhere, right? Which is nothing but loosely coupled. So Docker is implemented in the loosely coupled only. Docker, Kubernetes, these are all implemented in the loosely coupled, but Jenkins implemented in the tightly coupled, right? So that is why Docker is very popular now. So Docker, Kubernetes, these are very popular now. In case one microservice is down, nothing will be happened with the application, right? Yeah. Next one, fine. So before Docker, before Docker, what happened? So before Docker also we used to use some containers. Before Docker also we used to use some containers. So which are like LXC. LXC. LXC is a, it is a Linux container. Before Docker we used to use LXC. It's a Linux container. And also Jones. So these are all Solaris containers. This is Solaris container, okay? And also LMCI FI. So LMCI FI full form is let me container for you, which is Google container, which is Google container, right? So before Docker, we used to use these containers. These containers are very not very popular. These containers are not popular. So because these containers are these containers are platform dependent containers. These containers are platform dependent containers. Okay. So why Docker is very popular now? Why Docker is why Docker is very famous now? So because Docker, irrespective of operating system, we can run Docker containers on Windows, Linux, Solaris, even Mac OS, right? So that is why currently Docker containers are very popular now, very popular, right? So because irrespective of our operating system, we can run this Docker containers on Windows, Linux, Solaris, Mac OS, any operating environment, right? Yeah. Next one, Docker editions. Docker editions. We have two editions are available. First one is community edition. Second one is enterprise edition. So community edition is free of cost. It is free, no charges, right? So in our test lab we use community edition only. Enterprise edition is licensing license. Okay. So in real-time projects, always we use the enterprise edition. So in free test labs, free tier, we can use the community edition, right? So these are the Docker editions available. Clear, right? Any questions up to here? Anyone? Anyone having any questions up to here? Yeah. Now let's try to understand Docker architecture. Docker architecture. Let's go and discuss about Docker architecture. So before going to Docker architecture, let's try to understand virtual virtual server architecture. So before going to Docker, let's try to understand virtual server architecture. So in virtual environment, we take one we take one physical server which is high capacity server. This we can say base OS, base OS, base operating system, right? Yeah. So this we can say physical server. On top of this, we deploy. On top of this, we deploy one package which is we can say VMware or hypervisor or Citrix. So we take one server. On top of that, we deploy one package which is VMware hypervisor or Citrix. So this will allow you to create virtual servers. What is virtual server anyone? Virtual server and ఏంటి? What is virtual server? Anyone having idea? Online guys, what is virtual server? What is virtual server anyone? It is a imaginary server which is not a physical server, right? It is a imaginary server which is not a physical server, right? Yeah. So when we create a virtual server, that takes some physical configuration from physical server. For example, we are creating one EC2 instance in AWS. So that is virtual server. Virtually we creating, right? So backend AWS data center, they are providing some hardware in backend. So that virtual EC2 instance utilizing some hardware, right? Yeah. Same way in virtual environment also. So this is a base server. On top of that, we deploy one package which is a VMware hypervisor or Citrix. On top of this, we can create virtual servers like this. We can create virtual servers, right? So different operating environments we can configure here. For example, this is a Ubuntu server. So this we can say RHCL. This we can say CentOS. This we can say Windows. This we can say SUSE, Linux. Okay. So like this, different operating environments we can create here also, here also. These are all virtual servers, right? Different operating systems we can create, different servers we can use, right? So these servers utilize the hardware from base server only. So base server will have high computing power. So RAM, for example, RAM 48 GB, right? CPU 32 core, storage or SSD. SSD we can say 10 TB, like this. Okay. So whatever configuration is available on the base server, so that will be utilized by this virtual servers. Okay. Yeah. So when we use virtual servers, here we required, if you want to deploy OS operating system, we required ISO image. We required ISO image. So ISO image size would be 1 GB to not 1 GB, 6 GB to 18 GB, right? So ISO image size would be 6 GB to 18 GB, right? So when you restart the server, it takes 4 to 8 minutes. Okay, when you restart the server. Moreover, licensing is higher. License is high. Okay, yeah. And also when you deploy any packages, deployment and downtime, deployment time and downtime is high, right? So deployment time, downtime is high. So these are all drawbacks available, right? So for example, we are talking about ISO image size would be 6 GB to 18 GB. So on an average, for example, I take uh, 10 GB for each server, 10 GB for each server on an average. So 10 into, we have 25 servers are there, 5 into 5, right? So 10 into 25, 250 GB we need to spend for only operating system. Only operating system we need to spend 250 GB. So on top of that again we need to deploy applications, patches, drivers, right? We need to deploy all the plugins, everything, right? So it takes more space and restart time is higher, licensing cost is high, deployment time and downtime is higher. These are all drawbacks in the virtual environment. That is why to avoid this, project teams are looking for Docker containers. Docker container architecture. So in Docker containers also same way what we will do, we can take one server which is we can say, yeah, it can be any server, it can be cloud server, cloud server which can be EC2 instance or Azure VM or Google Cloud server, right? It can be any server. So on top of that what we will do, we can install one package which we can say Docker image. Yeah, this will allow you to create Docker containers. So in this Docker containers, what we will do, we can deploy different operating environments like Ubuntu, RHCL, Windows, right? And other operating environment like whatever you want, Solaris, whatever you want. Okay. Yeah. So when I run container, what will happen? Only library and binary files will be installed on this. Library and binary files will be installed on this container. When I run the container, only library binary. That is why, so this container size would be 200 MB only. 200 MB only. Okay. So when I deploy all the packages, every configuration, everything, so maximum it takes 650 MB, 700 MB only. Right. So when I restart this container, when I restart container, when I restart container, it takes how much time it takes? How much time it will take? Container restart. Yeah. So 15 seconds only, maximum 15 seconds. Okay. And also license cost is very less. No licensing. license license is there, very less costing, right? And also deployment time downtime is very less, right? Yeah, so that is why most of the project teams they are using Docker containers currently. So Docker is very popular now because very faster. It's a lightweight environment, right? So when we run any containers, so yeah, very quickly they run the containers will run, and applications also we can deploy very faster. And so currently we are using digital applications, right? Like so Flipkart, Amazon shopping site, so and also Danjo, Jepto, Blinkit. These are all deployed on Docker containers. So when we book any groceries, they deliver within 5-10 minutes, right? Because of backend, they have Docker containers. Okay. So this Docker launched in 2013. Docker implemented in 2013. Okay. Yeah. So after one year in 2014, Kubernetes released. So why Kubernetes immediately released? Because Docker also having some drawbacks. Few things, few drawbacks. That is why they release the Kubernetes. Kubernetes is advanced to Docker. If you understand Docker, you can easily understand Kubernetes also, right? So these are all the advantages. That is why. So currently Docker is very popular in the market, right? Clear, right, everyone? Now, how to install, configure Docker? Let's try to understand. First, installation we'll see today. So tomorrow we'll configure and we'll work on containers. Okay. Yeah. So Docker, how can we deploy Docker? How can we install, configure Docker? Let's try to understand. Any questions up here, anyone? See, these are the commands to install, configure Docker. So we required Ubuntu 20.04 is the stable version. You can use RHCL also, CentOS also, but Ubuntu is the stable version. Okay, you can take Ubuntu server and enable Alt SCP because backend some ports should be activated. Okay, and so this is the sudo apt-get update command. You can update this. After sudo apt-get install app transport certificate here. So you can get the package by using curl sudo apt sudo add app repository can add sudo apt get update again. So after that we need to set the policy. After that we need to install the Docker by using this command. After that systemctl status Docker. Check the Docker is running or not. These are all the commands, 8 commands we need to execute one by one.